Right. Hello. Hello, everyone. I know it's been a long day, and most of you are probably looking forward to the drink, so I'm going to keep it quick. As mentioned, I'm going to be talking about our approach on enabling a carbon-led design delivery. So, quick overview. So I'm going to start with a quick introduction about me and the team, our carbon approach and how that relates to One Click LCA, and then finishing off with some case studies of how we incorporated that and some time for questions. So probably worth starting off with, my name is in fact Charbel Charbel. That's not a typo. It is confusing, but it's easy to remember. I am an Embodied Carbon Consultant at AtkinsRéalis. So in case some of you don't know, it's previously known as Atkins / Faithful and Gold / SNC-Lavalin, which all sister companies, all combined in one AtkinsRéalis now. It's basically a worldwide engineering multidisciplinary company. I personally sit within the building design as part of infrastructure. Within building design, we have a sustainability team, which basically started probably less than 2 years ago, but it's very quickly growing. We have lots of expertise, including embodied carbon, building physics, passive house, general sustainability as well. A quick overview of the type of projects we do. So at the moment, we're working on Sizewell C accommodation campus, which is the accommodation that's part of the plant that's being built. Some work in Saudi Arabia on the Oxygen master plan. One that we recently finished and we're still working on at the moment even is Surrey Quay Station, which is a tube station in London. We have a lot of work with Surrey County Council as part of their framework for social housing and education buildings. We recently finished an extension to the Heathrow Airport, and finally Ederoth, which is an internal project we're doing on MMC social housing, essentially. To start off with, I'm just going to quickly explain about our carbon management process within our team. So we always try to start every stage with a carbon workshop, which is undertaken with all the disciplines in the team, to kind of just start the conversation about carbon, get it in the back of their minds, set the priorities of carbon within the design. We move on to training the actual architects and engineers involved to kind of inform them of what the priorities are, what they need to be thinking about, how they need to be leading carbon as part of that design, setting targets. And then we move on to actually measuring carbon. But the reason we measure carbon is not just to report it, but rather to reduce that carbon, which is the main purpose behind all of this. So we see measuring and reducing as kind of like an iterative process where it goes back and forth, measure, identify what the hotspots are, try to reduce it, and then measure again to identify what we actually did. Following that, we move on to reporting and kind of just having a standard process to understand what we've done, what worked, what didn't work. And then moving from there, we get some lessons learned of that whole process. And that, again, feeds into the same process again. And we do this at every single design stage. And that's how we learn from what we've done. And we learn what we can do better for the next stages. So for today, mainly going to be focusing on measuring and reducing. Obviously, we use One Click LCA as our main measuring tool within the team. But being a multidisciplinary practice, we have the added benefit of being part of the design team. So we sit within the architects, engineers. So we have I'd say probably like an added benefit of we can actually influence the design to a better low carbon design. So obviously the main thing that we focus about is upskilling the architects and engineers about what they can do better, integrating carbon as part of the process as well, and eventually getting a low carbon design. We've tried a few models of how we can actually do that. We started with trying to get the architects and engineers to do the One Click LCA models themselves. Obviously that didn't work very well, mainly because there was not a lot of consistency. Sometimes they would do it maybe too late in the design process, that it's too late to actually do anything with that data. So it's basically just a report, and we don't really want to do that. We want to use that to actually inform the design and reduce it. That's why we came up with our own process, which is we developed 4 different carbon tools, one for each of our disciplines. So one's for structures, one's for internal finishes, one's for facades, and one's for MEP. And the way we developed these is we worked with the individual disciplines to understand how their design process works, what their priorities are, and how and when would be the best time to bring in carbon into this conversation. And basically, we got them to be involved in this as well to tailor it to how best works for them. So for example, structural engineers like numbers, so we've developed a spreadsheet for them. Internal designers like images and diagrams and lovely pictures, so that's what it is. And basically, it's working with them to kind of understand what's the best way for them to bring carbon to the forefront, not it just being, oh, I have to consider carbon at the end, for it to actually be part of the design process. I'm going to quickly run through these. Not going to go into too much detail because that would be take me a lot longer, but just to show how it works, what the outputs here are, everything. I'm not going to be talking about MEP because that's still very much being developed at the moment, so I don't have much information to share on that yet. Starting off with our structures tool, so it's adapted from the iStruct tool that was already developed, but we made some changes to it to better work with how our engineers work. Essentially, they can input a few build-ups. There's also some preset build-ups that can be included there. And then finally, it just compares the different buildings against each other, either the whole building or the specific element. In terms of the internal finishes tool, we developed this based on the database from One Click LCA. And essentially, it allows to compare either specific materials against each other or the whole space layout in general. But the main thing we focused on this is we based the numbers that are in here on market averages, not on specific EPDs. And the reason for that is because when this is used at a very early stage, either REBA 1, REBA 2. So we don't actually have any information on what product is going to be specified. So in order to avoid that, we always prefer at an early stage to get the designers to use a market average. When we start getting into a bit more detail, that's when we offer them some low carbon alternatives. Say, for example, I want to go with a high recycled content. I want to go with this specific manufacturer. So it's very much keeping that to the later stages. But at the beginning, we try to keep a very high level market average comparison. And finally, in terms of the facades, the point of the facades tool is it doesn't just compare the cladding it on its own, but it compares the whole external wall buildup. So it includes all the layers, all the secondary structures, insulation, everything. It also has the option for them to input a specific thicknesses in case they want to make it bespoke to their project. And eventually, the outputs from it is not just the carbon value, but also the U values and the weight of the buildup that they do, because that is heavily going to affect the piling and the substructure that it's going to need. So those are also very important elements to consider as part of it. And the interesting thing is that they all have an export to One Click LCA button that we included. And the way it works is while they're all working separately, they all can combine into one click and into one Click LCA model for each project. And the reason why we found that very useful is while they're all working separately, informing their design, capturing whatever reduction they are doing, that still allows us to do our model for reporting purposes and to align everything together. And at the same time, because there's one Click LCA model, it is owned and managed by the carbon consultants, and that way we can do our quality assurance, we can make sure everything's right. If there's anything underestimated, overestimated, we always have an overview of everything that's happening. And that's worked very well for us so far, because it gives us the best of both, getting to be able to incorporate into the design processes, but at the same time, having that overview of what's happening and being able to monitor everything that's happening. So to jump quickly to some case studies of how we incorporated those into our projects, I've included 2 case studies, one that's an early stage and one that's a detailed design, just to show the difference between how we work differently on both. The first one is the Oxygen Master Plan, which is part of the NEOM development in Saudi Arabia. So we are currently involved in the northern southern cluster, which are basically master plans just south of the line, essentially. And the way this master plan is designed is basically it's a number of typologies that are outlined across the whole master plan. And the way we started, it's a very high level. We don't have a lot of information yet, but the way we are starting to kind of build a roadmap for carbon reduction is, at the moment, we took all of these typologies and we compared them for 4 different structural frame options. So a concrete frame, a steel frame with a CLT slab, and a timber frame. Obviously, the timber frame is the least, but we have to consider that in this geological area, timber is probably not the best option to use. However, the client was enthusiastic about it, especially for their low-rise buildings. So we're keeping it as an option, although it might not be the best. And then we also compared the different options in terms of different grid spacings. So obviously, with a bigger grid, you're going to need thicker slabs, and you're going to need more material, basically. So this is very much to kind of inform what the best way for us in terms of design of how to reduce carbon from an early stage. In terms of architectural finishes, as part of our design guidelines, we have a number of suggested finishes for both facades and cladding. So we used both data from One Click LCA and our finishes on our facade tool to kind of compare the different facade finishes provided for both, and the shading for both carbon, but also weight associated per panel. And then this is basically what we do at an early stage, but then how we move on to a later detailed design stage is that we take those individual ones and we actually compare the impact that they have on the substructure to kind of get a holistic impact result rather than just elemental facade elements. Moving on to the second one, which is a Surrey Quay Station, which is a tube station for TfL in Southeast London. Basically, this is being constructed now, so our involvement was a lot more detailed at a detailed design stage. And the way it works is, I'm not expecting you to read that table, it's just to kind of show how our process works is from the beginning of the design, we always like to have a workshop with all the disciplines involved. In this particular one, we also managed to have a workshop with the contractor and the client as well, because everyone's supposed to be involved in this process. And the way it works is we start brainstorming some ideas of how we can reduce carbon in terms of design, not just specifications, but also design impact as well. We map out some opportunities, the constraints related to them, what their benefits are, and who the people responsible for these are. Following that, we received a very detailed spreadsheet that was considered a carbon assessment that was developed before we got involved. But it was very, I would say, non-useful because the main purpose for it is just to report one number at the end. So the first thing we did when we got this is to transfer that into One Click LCA. With all the added benefit that it has, it's a lot more organized. We were able to actually use that data to inform the design, identify what the hotspots are, basically identify what the biggest contributing factor materials, and obviously all the benefits that One Click LCA has. And from that, we were able to incorporate a number of carbon reduction opportunities. Firstly, focusing on design changes. So we first were able to incorporate a CLT roof with glulam beams. In the parts that we couldn't have a timber roof, we tried to reduce the spans, and we moved away from a post-tension slab into a normal metal deck, composite deck. And we also reduced the depth of the piles, which saves significant numbers of carbon as well. In terms of finishes, we also tried to reduce ceiling finishes wherever possible, wherever acoustics would allow it. And we opted for a bio-based wood wool, basically, finish, which was a lot more low carbon. In terms of facades, we were a bit limited on our options, mainly because TfL have a lot of maintenance requirements, especially with public-facing areas. But we managed to incorporate a brick, which is K-brick, which is made of construction waste. But now we know about Ibstock, so we'll keep that in mind for later. And in terms of metal cladding, we shifted away from aluminium ones, and we managed to incorporate low carbon metal ones as well. And it's been really good. This project is now being put forward for an ICE Carbon Champion Award, just to show it has done a significant amount of work to reduce carbon. That's it for me. I think just a few key takeaways from my presentation. Obviously, One Click LCA are the ones who got us here today together. So just think they're a very valuable tool, and in my opinion, they're probably one of the best on the market. And they really serve as the golden thread that brings in all our carbon information together. We have integrated One Click LCA in all of our internally developed tools, and it's been very helpful to kind of bring in carbon into the conversation and deliver low carbon results. Yeah, I think we used it in both early stage and design stage, and it's really good for both. In terms of decision making, I think we particularly found it better for detailed design, mainly because of how extensive the database is. We are currently using it for the first time on an as-built assessment. So the last project I mentioned, it's being built now, and we're doing an as-built assessment for that as well. And finally, yeah, I guess we use One Click LCA every day, and we really like it, and looking forward to see what comes next. And yeah, hopefully we can try and solve the climate crisis together. Thank you. Any questions?